In this video, we're going to solve applications involving probabilities using sampling distributions of sample means. The machine is set to fill paint cans with a mean of 139 ounces and a standard deviation of 0.20 ounces. A random sample of 35 cans has a mean of 138.9 ounces. The machine needs to be reset when the mean of the random samples is unusual, meaning that there's less than a 5% chance of that happening, which happens when we are outside of the -2 standard deviation to 2 standard deviation area. Remember, by the empirical rule that 95% of the time we're within plus or minus 2 standard deviations of the mean. So does the machine need to be reset? Well, let's first find what a standard deviation is for the sampling distribution. So we have 0.20 divided by the square root of 35. And so let's round this to 2 decimal points, let's say, because we've got 1 decimal point here. So our standard deviation for our X bar is about 0.03 ounces. And we need to take this 139, that's our mean, plus 2 times 0.03. And we're going to get an upper boundary of 139.06. You'll understand why I'm writing it in this interval notation next chapter. And minus, and let's call this 138.94. If it's within these boundaries here, it's what I would consider to be usual. If it's outside those boundaries, I would consider it to be unusual. So 138.9 is smaller than my lower boundary here. So yes, the machine needs to be reset because it's very unlikely that you would randomly sampled 35 cans with a mean of 138.9 ounces, because it does not lie within the range of the usual event, namely within 2 standard deviations of the mean of the sample means. So again, we're using an idea that comes up later in chapter 6 called a confidence interval. That's basically what the entire idea of chapter 6 is, and we're introducing you conceptually to a confidence interval right now. But if I wanted to be 95%, within the mean, like this, within 2 standard deviations to the right or to the left of that mean, what would I use as my boundaries here? And then if something is outside my boundaries here, it would be considered unusual. It's one of the applications of the ideas that are going to come up in chapter 6. Let's see what's going to happen here. The lengths of lumber a machine cuts are normally distributed with a mean of 96 inches and a standard deviation of 0.7 of an inch. What is the probability that a randomly selected board cut by the machine has a length greater than 70 or 96.25 inches? So we're going to do this with technology. Second distribution, normal CDF, lower boundary we want to be 96.25. Upper boundary we want to be unbounded, so I'm going to use 1 times 10 to the 99th power to represent that. Our mean is 96. Our standard deviation is 0.7. Everything about this first question is a distribution of x's, and this is what's to the left when I do normal CDF. Oh no, this is to the right because I went unbounded to the right. So this is 4 decimal places, 0.3605. If I had used my table that went to the left, I'd have to do 1 minus in this situation because it went to the right. That's what I was starting to tell you. All right, but technology helped me and let me choose my unbounded region to the right so that I shaded to the right and not to the left. Okay, now the question is going to change. If a sample of 45 boards is randomly selected, what is the probability that their mean length is greater than 96.25? So we're going to come back in here, do normal CDF, but we're going to change the standard deviation now to be divided by the square root of 45. So that we get a distribution of sample means now. We're going to paste that, and this probability is 0.0083. See how those probabilities changed and it became more unusual. It was not an unusual event here to get one board that was this long, but to get a mean value of 45 boards that was that big, because some would be bigger and some would be smaller. That would be highly unusual here, and we would not expect that to happen. All right, I think that's it. Yes, it is. We'll come back next time and we will be talking about 5.5. See you for the next video.